I really thank you for coming. We have a guest, Dr. Richard Tsai. He is a professor of automation engineering working for the National Formosa University in Taiwan. I met him 3 years ago in one of the World Aquaculture Congress. I think it's 2008. And then we discussed few things. And last year, actually, Jordan Marshall and me, Dr. Gillespie was there as well. We wanted to develop something, as well as Dr. Cheng from mechanical engineering, write a project on how to keep our water ponds, lakes clean. So he has actually discovered a machine. He named it what jet, right? Yeah. And he wants to talk about it today. He's actually here not to visit us. He's here with his team from Taiwan, because Indiana and Taiwan are actually doing their first collaborative symposium on campus for next 3 days. It's called ITTTES, right? Yeah. Indiana, Taiwan Technology Transfer Entrepreneurship Symposium. Okay. So he just took out of the symposium just to come here, visit us, talk to a few of us, if you could do some future collaborative research with us and other universities. Dr. Tsai did his PhD from Imperial College of London in 2005, yeah. Right?
On
1997.
Not 1897.
No, 1897. he sent me a small, short bio, and he wrote 1897. I said, oh my God, is he a real person or a ghost?
I must be a Buddha.
So anyway, it's good to have Dr. Tsai here, and without further delay, this floor is yours.
Okay, thank you very much. I'm used to mouse, so if we can stop anytime if you have questions. And I'm a mechanical guy, and you are biology guys. Before year 2005, I never think that mechanical guy has a relation with biology guys or has anything to do with biologists. I did this is very occasionally, just it's an accident, Somebody just told me that there is a problem with aerators. And I didn't believe it in the first beginning. And then I found out, and I confirmed this information. Say yes, there are problems with aerators, just by very basic fluid mechanics. So I will say something about fluid mechanics, and it will involve something about ecology and biology. And you will respond back about the biology side. It's a free discussion. I'm strong in fluid mechanics, but I'm quite weak in biology and ecology. So I would be happy if we enjoy the discussion. Here we start. Yeah, the main topic is cruising jet aerators. I will explain later. So, and the target is a sustainable Earth, an integral solution of water, food, and energies. So, because we can increase fish production with water jet. Okay, here is the outline, and then this is the human growth, more than 7 billion. So we are short of water, food, and energies. And we need to make best use of water and energy to produce food. Best use. Okay, so according to Sophia report, every year we need to increase another 2 to 5 million tons fish. And that cannot be done by fishery. It has to be agriculture, as they say, UN says. Okay, here is the existing aerators. So they are existing. If you look at this part, then you know all these aerators are limited use, surface aerations, short aeration times, and short working range. However, they are really useless to the poor bottom where benzo lives. So this is aerator too, and they are only do something on the water surface where the benzo lives in the poor bottom, and the depth of water for agricultural pools typically deeper than 1 meter and usually 2 meters. And if a pedal wheel or aerator do something on the water surface, you can imagine they really do nothing useful to the poor bottoms. But poor bottom, for poor bottom, you have peatry organic, as we said, sediments, and that come from feed residues, excretion and dead body of fish and animals. So you have big guys, peatry organic, and sediment in the poor bottoms. But you are doing very hard in the water surface. So that means you are doing something not really useful to your animals. And according to that, so many guys try to change. So they push water from the surface to the bottom. Again, they generate another problem. They dig holes in the poor bottom, but they push it, but they don't really clean it. So what I would expect is this way. So if we are in this room, we have powerful hoover. If we don't move this hoover, they can do nothing. They only can do something around this hoover. They only can clean everything around this hoover, but they can do nothing far from the hoover. If we have iRobot, we saw a cruising hoover. They can clean everything when it closes. So that's my idea. If we can let something close all the pool, then they can clean everything once it passes. That's my idea. So maybe I can call it iJet, but iRobot is better than a powerful hoover. So what I do or what I mention is, if you have sediment here, so you have low oxygen here. You have many nitrogen, ammonia nitrogens, and they are harmful to your benzos. And then if you pump in this bad water up to the air, then they will be exposed to the air, and some bacteria may be killed by sunshine, and organic may drop down to the water surface and uptake by algae, and algae become biomass. And algae can produce photosynthesis. They enlarge photosynthesis reactions, and the water flow comes down. So you transform putrid organic into biomass, and this biomass produce oxygen and food to your benzos. So I call it this way. I call this function is putrefaction and the regeneration of waters, and regeneration of your putrid organic and putrefaction of your water. Okay? So here, increase DO concentration, remove ammonia nitrogen. Here is the demo. So if we have pool, we can pump water from the very bottom, down the bottom, very close to the bottom, and then it can do 3D aeration and flow convections. So it's not a pump fixed in somewhere of the pool. It's a moving device. So it sucks bottom water from this place, injected to outward about 10 to 15 meters. But it walks. It can walk up to 500 meters, as I have tested. Usually I let it move 200 meters. A typical fish pool in Taiwan is 50 times 200 meters. That's typical. 50 in width and 200 in length. And the depth is between 1 meter to 3 meters. Depends on the fish species. Okay, here's some flush. So we have pumping water everywhere up the bottom and inject it to somewhere. And we do shellfish. We do shellfish because shellfish doesn't move, so that we can identify where is its effective range. And we do swim also because they are weak swim ability. They don't swim a lot, so that they can prove if our water is good or not. Okay, here is the mechanical performance. So it can iterate. Its working range is something like 1.5 in depth, 300 meter to length, and 20 meter width. It can inject so much, but it is useful enough for a pool of 50 times 200 meters. If we say pedal wheel, then its working range is something like 4 meter times 0.5 times 0.1 meter, because the pedal only do 10 centimeters. And then its working range is something like 15 to 25. And this one is 1 meter after pedal wheel. If you don't measure the flow speed, we measure the velocity around the pedal wheel. If you are beside the pedal wheels, so you don't measure the velocities, you cannot. And depth, we can very close to pool bottom and their upper surface. The length can be up to 500 meters. So everything is kind of ratio. It's not percentage. The fact, it's a physical effective. It's always 10 times. If we check the aeration time, flow rate, you don't believe, say, a pedal wheel can do 1,000 liters per minute. Only pump can do that. So the advantage and disadvantage are very clear. So then I keep going on with this machine, although I'm a mechanical guy, and I keep looking for biology guy or agriculture guys try to develop this. Okay, then what we expect, what we have done is stocking density. It can improve something like 20 to 35%, and feed to mean ratios, because we transform the Petri organic to biomass, so they can reduce 10 to 25%. And growth rate is more powerful in shellfish, hard clam. That can be done by 30 to 50%, because clam doesn't swim, they don't move. and it's quite useful for them. And then for shrimp, it's a little bit less, and for fish, again, it's a little less because fish, they swim themselves. And power consumption is quite clear. We can use, the most important is we don't need well water. We don't need to pump well water from the deep bottom. Most fishermen, they pump well waters to change water so that they can, stabilize the water quality. But if you use this one, we don't need to pump water from 70 meters below the ground. And if you do 1 hour pumping from 70 meters, actually you can do 35 meters with water jet. So that's our benefit.